in this problem, we begin with 100. And usually in these types of problems, you want to continue this sequence or series until you find a pattern. And that's what we're going to do here. We're going to continue this sequence based on the rules, follow the rules, and then we're going to see if we can find anything special or unique. Okay, so 100 is not divisible by 3, so we add 10. 110 is not divisible by 3, so we add another 10. 120 is divisible by 3, so we divide by 3, divide by 3, and we got 40. And for those of you who don't know the divisibility rule of 3, make sure to learn that before solving this problem. I'll probably make a video on all the divisibility rules in the sometime near future. So yeah, now let's continue on the problem. So 40 is not divisible by 3, so we add 10 and we get 50. 50 is not divisible by 3, so we add 10 and we get 60. And then 60 is divisible by 3, so we get 30. Oh wait, so sorry, 20. And then 20 is not divisible by 3, so we add 10. 30 is divisible by 3, so we get 30 is divisible by 3, so we divide by 3 and get 10. 10 is not divisible by 3, so we add 10 and get 20. And then we add 10 because 20 is not divisible by 3, we get 30. And then we divide by 30 as well because 30 is divisible by 3. And you see something special here. Okay, so at the beginning, we just have these large numbers. We keep on going down until we reach 20. And as you see here, we have a repeating sequence, 20, 30, 10, 20, 30, 10. That's going to help us solve this problem. So it's asking what value results if you perform this operation 100 times. And the commas show an operation being performed once. So that will also help us. Let me erase this. So if this operation is performed 100 times, we have the first time, the second time, the third time, the fourth time, the fifth time, and we'll stop there. So the operation is being performed 5 times, and those 5 times really don't do anything for us because these are just random numbers at the beginning, at the start, and yeah. So we start with 60, and really this operation doesn't really matter too because it's including there will never be another operation where we go from 60 to 20. So we already performed it 6 times, and now we have 94 operations left. You want to see the 94th operation. Okay, so we just draw our barrier right here, and then our barrier right here too, because it repeats every 3. Okay, so this is our first. We'll start brand new. This is our first operation. This is our second operation. This is our third. Let me erase this. This is our third operation. And then this is our fourth, fifth, and then sixth. Obviously, we don't count the ones before because we already counted them. We want to see what the 94th operation is, starting with our new sequence. Okay, so we have 20. So this is our first, second, third. If it repeats by 3, we know what to do. So 93. So it happens 93 times. No, not 93 times, but 93 is divisible by 3, and that means the sequence will happen 31 times. So this entire sequence will happen 31 times. And if we add 93, we'll see eventually that the 94th operation will be from 20 to 30. And if that didn't make sense, let me re-explain it right now. So these operations don't matter because we already, because they're not part of the repeating sequence. So we already subtracted them from the grand total of 100. So we now have 94 operations left. And we want to see what the operation is when 94 operations run out. Okay, so 20, 30, 10, that's a repeating sequence of 3. And if it's a repeating sequence of 3, we'll see that eventually, if we just add 3 on and on and on, we'll see that the 94th sequence corresponds to the first operation. And that's the operation between 20 and 3. So the value that you get is obviously 30. If there's any